Hello, everybody. Welcome to this event, and thank you all for joining. We're very excited and happy to have you here with us for another one in the series of our NDB Tech Talks. This specific edition is targeting the release that we've recently pushed out for NDB 2.10. We'll show you what the main highlights of the release are, as well as how to use them, including a couple of quick demos. For a housekeeping perspective, I wanted to let folks know that we will be looking out for questions during the actual conversation as the presentation is unfolding. But please remember to use the Q&A feature, the Q&A tabs, rather than the chat feature, so that we can properly manage the incoming questions. With that being said, we would like to start by introducing you to the crew that will be showing you the highlights of the 2.10 feature set today. I would like to start by myself, Mohammed Karam. I am on the product management team. I've been with the product for a few years now, and representing MySQL as well as MariaDB and the HA and DR spaces. We also have my colleague from the product management team, Anand Shandak, who is a group product manager on the same team. Anand has been with us for a few years as well. So thank you for joining, Anand. You can see him on the video there. And Anand is also in charge of the Postgres databases as well as other features in the product. We are also fortunate to be joined by Ishwar Rao from the NDB engineering team. Ishwar is a database engineer, and he will be driving us through a major chunk of the demos that we want to show you later in this conversation. So with that, let's move into the actual introduction of NDB for people who may not know this. Many folks would probably be very familiar with this schematic, but I'll quickly go through it for the benefit of people who are joining us anew. NDB is a database management platform that basically functions across hybrid environments and multiple clouds. You can start by running your resources, your assets, your virtual machines, either on premises or on AWS and Azure. And wherever you choose to run them, we support multiple hypervisors as well. We support AHV and ESX. And those database server VMs can run a multitude of different database engines. We support SQL Server, Oracle, Postgres, and EDB. We support MySQL and MongoDB and MariaDB as well. We also support the pgvector extension. Those databases being supported, you can then unlock a variety of very critical lifecycle operations and database automation mechanisms. We dramatically facilitate the process of provisioning. You can get very rapid thin clones, which are storage efficient. And we support storage scaling as well as patching of your database engines, as well as fast backup and recovery, with many security features built in across the different database engines. Different features are obviously supported depending on which database engine is in question. But there is a huge benefit to sort of getting that singular lens across all of your database engines and unifying the experience that your team gets when they are executing all these operations across the variety of different underlying database engines, as well as the underlying host architecture that you have, whether that be on premises or in the public cloud. All of these automations and lifecycle management operations are exposed via CLI, API. We also have a Kubernetes operator, as well as from the graphical user interface that is exposed with NDB. So with that in mind, let's actually walk you through some of the more recent updates to our release feature set, starting from NDB 2.8, which was released in April of 2025. Some of the highlights there include enhancements for SQL Server, including patching on a bulk level. Some time machine enhancements were also added, including more insights into health status, as well as user experience enhancements. In 2.8, we also extended support for all the database engines that I previously mentioned to run on NC2 and AWS specifically. So you have that liberty now across all the supported database engines. And we also added support from a version perspective for MongoDB 8, as well as Postgres and EDB 17. And then the 2.9 release came in October of last year, where some of the key highlights included disaster recovery support on a native database engine level for Oracle using Oracle Data Guard. We also brought multi-database group support for multiple AGs for SQL Server. Further time machine improvements in terms of storage reporting. We also brought in support for interoperability with Cohesity on Postgres. And 2.9 was the first release where MySQL high availability support was rolled out via the API and CLI. And we'll tell you a little bit more about that for today's session as well in a few moments. Many security updates also came in 2.9, including support for WinRM over HTTPS, as well as running SE Linux in enforcement mode, as well as supporting full backup and restore of the NDB control plane itself, which is the part of the system that actually makes NDB run, as opposed to the user databases, which we refer to as the data plane. And for today, we wanted to discuss what's coming in for NDB 2.10, which came out earlier this year. One of the main, again, I'll go through these very quickly, but we'll walk you through in detail in a couple of moments. We're very happy to have integration with Ops Manager for MongoDB sharded clusters. A lot of MongoDB goodness is coming in 2.10, including data protection features such as snapshots with restore and point-in-time recovery for sharded clusters. SQL Server improvements, including cluster IP configuration for specific IPs during provisioning. And another very popularly requested feature was configurable drive letters, also for SQL Server. And we're also extending the MySQL HA functionality to the GUI. It's now available in the user interface as well. We added security features for MongoDB to support KMS key rotation for replica sets, as well as single instance variants of MongoDB. All right, so let's take a slightly more zoomed in look at these feature sets. So let's start with, I think, one of the marquee features coming in for 2.10 was a lot of goodness coming in from MongoDB sharded cluster. So once again, this is we're very happy to report that this is based on a very close integration partnership with MongoDB themselves. So they've been able to take a look at some of these functionalities, and they were able to conduct a certification. It's basically something that MongoDB certified for the automated snapshots, including for restore and shard consistency validation, the one-click restore feature. There is now support for point-in-time recovery, where you can restore to a very high level of granularity on a second-by-second level. We have, as I said earlier, close, very, very tight integration with Ops Manager. So you can register existing Ops Managers which can coexist with the NDB control plane automations for the sharded cluster, and thereby leveraging the best of both worlds, as well as NDB simultaneously. For saying with MongoDB, we're also now supporting KMS key management with Thales KMS key rotation, as well as certificate updates. So this boosts your ability to stay compliant within your requirements. The other thing that a few other updates also came in with this release, predominantly for SQL Server. As I alluded to earlier, there was the SQL Server VM specification, and across the cluster and AG and FCI levels that allows you to now select specific IP addresses during provisioning in order to adhere to specific configuration and topology requirements that you may have. while simultaneously defining whichever listener names and ports you actually want to get to specifically. Also, staying within SQL Server, as I said, you can specify custom drive letters for your data, for your logs, as well as for TempDB, where customer topologies require that for compliance or scalability requirements. And lastly, we have the set of MySQL HA improvements now supported across the gamut of interfaces that we have previously alluded to for across the API, the CLI, and now with 2.10 across the user interface as well. And hopefully we'll have a chance to show you those later in today's conversation, time permitting. Okay, so that was a very brief overview. I will now get into a little bit more details with Anand's help on MongoDB specifically before getting back to the other database engines. MongoDB will be covered in full color and full detail by Anand. Anand, whenever you're ready, please take it away.
Thank you, Mohammed. Thank you for that introduction. Hey, folks, I welcome you to this webcast on NDB 2.10. Just like Mohammed said, my name is Anand Chandak. I work as a group product manager on the Nutanix Database Service team. Within the team, I own MongoDB and PostgreSQL and a bunch of other product-specific use cases. Right. So without further ado, let me walk you through some of the key capabilities that we introduced in 2.10. And I'm super excited about this. Right. So the first up is the Ops Manager integration for Sharded cluster. So many of our enterprise MongoDB customers are already running Ops Manager. It is managing their agents, their monitoring, their existing integration. And one of the key requests that we heard from them is when NDB comes in, how would these two work together? So you can think of it as two brains working together. Ops Manager continues doing what it's good at, like in terms of alerting, monitoring your existing workflows and integration. And NDB sits on top and handles the sharded cluster lifecycle management, stuff like provisioning, patching, data protection. Now, we have a demo lined up also for you. But essentially, to set it up is very, very simple. You simply register your existing Ops Manager instance. And in the process of doing that, we ask some basic parameters, stuff like API key, the endpoints, and so on. And you'll see those in a lot more detail when Ishwar comes to demonstrate that functionality. Okay. So you simply register your Ops Manager instance into NDB. And as you can see, the UI on the right shows how straightforward that is. Then NDB automatically enables the required agent, automation, monitoring, backup, without any manual setup on each node. So the workflow is like this. You onboard Ops Manager onto NDB, and then you associate a sharded cluster with that Ops Manager instance. Now, for the customers who've been a little cautious about adopting NDB because of existing Ops Manager investment, the way we see this kind of removes that friction. Now, once your sharded cluster is under NDB management, the obvious next natural question is, what does data protection look like? Mohammed, next slide, please. Okay, so for those of us who are familiar with sharded cluster, a sharded cluster is genuinely hard because it has multiple shards, right? And then there are many other moving parts, routers, config server, and so on. Right. So when it comes to backing up a sharded cluster, it's genuinely harder than say a single instance backup. In this case, you are snapshotting multiple shards and a config server, and they all need to be consistent with each other. Now, getting that wrong means a restore that looks successful, but it isn't. So what we've shipped is a MongoDB certified solution. And this is an important distinction. It's a MongoDB certified solution, right? What that means is Mongo has validated this approach and not just us. Right? So the snapshots are automated. They have configurable frequency. You can choose hourly, daily, weekly, monthly. And the restore is one click. And NDB validates the shard consistency automatically before completing it. Right? And you can also pin the backup to a preferred node. And this is important because for a large cluster, when you don't want backup I/O on your primary, right, you can choose the node that you want to use for your backup node. In our internal test setup, we have validated the restore with multiple terabytes. And what we found is using the NDB plus Ops Manager combination, we were able to perform those restore in few minutes. Now, if you compare that to what, let's say, some of the native solutions, right, MongoDB dump or MongoDB restore, at the scale that I'm talking about, it's a significant difference, right? So if you're in the middle of the recovery situation, right, that does matter. But if you think about it, the snapshots only get you to the last schedule point. What happens when something goes wrong in between? That's when the PITR comes in. Mohammed, next slide, please. So what PITR or the point-in-time recovery adds is a continuous oplog capture between the snapshot. So the idea is you can restore it to any specific seconds within the recovery window, not just the snapshot time. So you can think of a practical scenario where something goes wrong, let's say 3 p.m., right? Your last snapshot was midnight. Now, without PITR, you're potentially losing most of the day of a data, right? With this, you pick the exact timestamp before the incident and restore to that down to that second. Right? As you see in the UI, it's the for those of you familiar with the NDB time machine, this may look familiar, but those who are not, this is a timeline view. You actually get to select the date, pick your point of time, and initiate the restore. The interface also shows the snapshot markers and continuous coverage, so you know exactly what's recoverable. Now, with this, right, the continuous oplog capture shrinks your RPO from snapshot interval down to seconds. Right? So for customers who are running MongoDB for transactional workloads, that's a meaningful difference in what actually recoverable. Now, if I move from customers in a regulated industry, the data protection isn't just about recovery. It's also about encryption and key management. So that brings to my next slide. Next slide, please. Which is about the Thales KMS key rotation, right? So now this one is specifically for customers who are running MongoDB with encryption at rest, right? So when you store the data, we already support encryption on the wire, right? For those customers who are looking at data at rest and encrypting that. So we integrate with the external key provider, in this case, Thales KMS. Right. So here in this case, and this is one of the requests that comes regularly from customers in the regulated industry, banking, financial services, and so on. Right. So here, when the TD is enabled, there's typically a compliance requirement to rotate the master key, encryption key, on the defined schedule. Now, if you look at it, this was a manual process. Rotating the key identifier, updating the KMF client, and the CA certificate. It used to work, but it was kind of operationally tedious and not audit friendly. Now with NDB 2.10, we add the API and CLI support to fully automate this. The key rotation and certificate updates are now scriptable and auditable. Now, as you can see, the value is straightforward. You meet your compliance requirement without manual intervention and have a clean audit trail to show it off. Right, so that's me covering the high level like feature level capability, right? And now before I hand it over back to Mohammed to cover, right? So I want to I mentioned in one of the earlier slide, I want to give you some context on where the MongoDB partnership stand, because it's relevant to why the certification we've been talking about actually means something, right? So Mohammed, if you can go to the next slide, please. So what I'm showing on my screen is a MongoDB screen captured here. So as you can see, Nutanix is officially listed on the MongoDB.com partner space as their official technology partner. The Sharded cluster backup solution we just walked through is built on MongoDB's official third-party backup integration technology, right? So it went through the MongoDB partnership evaluation process, which is how we got the technology partnership badge under the areas of partnership excellence. So what that means practically, if you are a MongoDB customer and you go to MongoDB partner page, you'll find the NDB there. And if you notice, there is also a test drive option directly from that page. Right? So this is, this is not just us, Nutanix, saying the integration work. MongoDB has put their name behind us. So that kind of covers the key features we shipped in 2.10 for MongoDB. I'll pass it on back to you, Mohammed. And for the folks, like I said, there is a live demo that Ishwar is planning to show of all the capabilities that I spoke about. Mohammed, over to you.
Excellent. Yep. Thank you, Anand. Much appreciated. Looking forward to that demo. All right, so let's go through the rest of the features that have been released for other database engines. We're pretty excited about some of these that we wanted to sort of highlight with you guys specifically. First among which, for our SQL Server users, a couple of long-standing features that were very highly in demand were the ability to to explicitly select IPs and listener controls for SQL Server components within NDB. So what you can do now is you can go ahead and tell NDB manually which specific IPs you want for the database server VMs, for the WFC cluster IPs, as well as for the listener IPs and for AGs and the FCI virtual network IP. Not only that, but you can also specify custom AG listener names and ports. This is supported across the gamut of configurations for SQL Server, for single instance, for availability groups and FCIs. This works obviously with static or IPAM VLANs, not for DHCP. People have been asking for a long time. This gives you the ability to configure your topology according to your own specifications, according to how you've managed to partition your IP pool. And in some cases, it allows you to recover connectivity with a specific set of IPs that you had perhaps previously configured on a specific application, or it gives you the liberty to have that additional level of control in your own environment. So again, long-standing feature request there, and very glad that it's been delivered to those who are looking for it. Again, this still happens within the same provisioning workflow from a UI as well as from the API CLI. So it's the same unified interface and very straightforward operation that do not require you to go back to the provisioning process and add manual fixes after you've actually deployed it. So that was the number one thing that came in for SQL Server. The other thing that came in also was in many establishments, there are custom configurations that teams have for layout for their SQL Server configurations. For example, there may be custom drive letters that they have established as standards for different components, for their data, for their logs, for their temp DB. Now these can be added and configured from NDB as well, allowing these teams, enabling them to support those standards and comply to them, and basically leverage the benefits of doing that, including scalability and reliability for their backup stories and so on. So this is also something that has come in, again, from the same workflows. You don't need to do anything post-provisioning, and you can check all those security and compliance from the get-go with NDB. The other thing that has come in, and again, hopefully we'll have time to show you this in an epilogue to the demo today, is for those of you who have been using MySQL, you know that we've recently released HA support, with starting off with the API CLI. Now you can provision MySQL HA clusters on InnoDB via the group replication stack with MySQL Router or MySQL Shell. not just via API CLI as was available in 2.9, but also with the UI. Very similar workflows, and hopefully, you will get a chance to show you these very straightforward mechanisms via the UI while retaining full control over and a very diverse configuration and parameters. This likely reduces the time cluster. There's a reduction in the manual steps, and it's very straightforward. It's not complex. It just basically makes your productivity booster across the board. So that is also something that has come in. From a version support perspective, we've added support for new operating systems and DB versions, specifically RHEL 8.10 and 9.7, Rocky Linux 8.10 and 9.7, as well as Ubuntu 24.04. All right, so that is the background in terms of what we've been able to do. In a moment, Ishwar will get a chance to spin up the demo for MongoDB. Ishwar, whenever you're ready, please take it away.
Thank you so much, Mohammed. Thank you so much, Anand, for covering the ground. And let's jump into the demo session. So let me share my screen and let's start doing it. Okay, I hope you guys are able to see my screen, and you should be able to see NDB's control plane. And Mohammed, can you confirm that for me, please?
Yes, we can.
Perfect. That's great. So thank you so much. So Anand spoke about the integration between MongoDB and NDB, right? So when we are talking about integration between NDB, MongoDB Ops Manager, right? So the first thing is that we need to understand that there is an Ops Manager and NDB should be able to communicate to that. So the first step, what I'm going to show you guys is that how exactly we are going to register our existing MongoDB Ops Manager to NDB. So this is the hamburger icon where I can use it to pop up all the options what I have. And here I have an option which is called settings. And under settings, we have in 2.10, we have introduced a latest feature which is called MongoDB Ops Manager. So if I just click on MongoDB Ops Manager, I'll get an option to either I can create an ops manager's entity in NDB, which will allow me to talk to that ops manager. So for that purpose, I just need to click on add button and I can give a friendly name to it. Let's say ops manager itself. And if I want some sort of description here, I can just go ahead and I can provide that. And for now, I'll just leave it blank. And the next option is the communication between NDB and Ops Manager. That happens over HTTP. So we have both the protocols available, which is HTTP or HTTPS. So whatever is your choice, whatever the organization requires, you can use that. So let's say for an example, I use HTTP for now, and I just need to provide an URL of an Ops Manager. So I just supply that. And if you are aware of Ops Manager, right, for communication purpose, it would require a public key and a private key, right? So Anand was talking about it. So this has to be collected from Ops Manager. We assume that your Ops Manager is all up, everything works perfect. And we just need to supply some public key and private key. For an instance, I'll just give some dummy number here. Just dummy private key and public key, and I just need to click on submit. Once I click on submit, I will be able to see an entity here. So as soon as I click on submit, an operation will get triggered in NDB, and I should be able to see an operation, something like register ops manager. If I expand this operation, you will be able to see it has just taken 2 seconds just to identify, associate that entire, or probably I should say register that ops manager to NDB. And it did a lot of pre-processing, verifying whether the ops manager is reachable from there, all the network and all those things are well stable. If there is any sort of prerequisite we have to identify, it validates that. And finally, it registers that ops manager to NDB. Once it's done, I will be able to see an entities, something like this. I'll go back to ops manager, something like this. So I have two ops managers. So definitely you don't have any sort of limitation like you can have only one ops manager associated to NDB. If you have multiple ops manager in real-time scenarios, you might have a DevOps manager, you might have a QA, or probably definitely a production one, right? So if you have different ops manager, you can go ahead and you can associate with them, and you will be able to get the ops manager link and something, and I can just go ahead and I can copy the ops manager link and I can just paste it here like this. So I have already pasted and I have already logged into this ops manager, and now this is able to associate to that. So that's the first part of it, where we were able to see that NDB was able to talk to ops manager, it was able to connect to it. And now the next part comes in, which is the real giant, which is like provisioning of a sharded cluster. Sharded cluster, right? So if you're aware of MongoDB and sharded cluster, you can have multiple replica set within a sharded cluster, which are generally called shards, right? So they all are associated and they form a cluster. So which means that you may have so many nodes within a single cluster of database, which is really tedious uh, to manage its infrastructure level thing, database configuration, and all those things. But here we have sorted it out all, and now with few clicks, you would be able to provision a sharded cluster and associate it or probably onboard that sharded cluster to Ops Manager. So I'll quickly go to the database page here using that hamburger button, and under the database section, I can just go ahead and I can start provisioning things. So I'll just click on source and I can click on this provisioning. And from provisioning, I would choose a sharded cluster to provision. So once I click on sharded cluster, it will give me some information about profiles and all, which is, I'm sure if you are aware of NDB, we need something called software profile, which is nothing but an OS image or your template image, which you would like to be available or to be applied, or probably I can say that the base image of your database VM, right? Whether it's OS, whether the database software, all those stuff gets carried away with that. So the software, the networking profiles, or a compute profile is your choice. Like if you want to create a compute profile, let's say that you want to have a 16 GB of memory with 16 CPUs, you can create compute profiles and all, and you need to have all those things ready. So once your profiles are ready, we can go ahead and we can start performing the provisioning work. And I'll just click on start provisioning. Once I click on start provisioning, it will ask me for the sharded cluster name. Let's say for an example, I give it like sharded cluster. And again, some description if you want. You can, or else it would be an optional thing. The next thing is the Nutanix cluster. If you have a highly available infrastructure where you have multiple Nutanix cluster associated with that, and your NDB is an HANDB, so you would see all of them listed here. So for this instance, I have only one, so it gives me an option of this only. So I'll just select that. And the profiles, what I was talking about, right? So which is like network profile, I have already pre-created that. So that's why I see the shard profile and a software profile, which is nothing but your OS image and software binaries, all those things combined in a single place. That is called software profile. So I have pre-created that and it's ready. Once I have that, if you want to use some SSH public key for connectivity and all those things, they are optional. If you want to do that, you can go ahead and you can do that. And I'll just click on next. The next step is like, how would you like to see the instance name here? So I would just say, let's say for example, sharded cluster. And now what NDB does is it will go ahead and it will create a default database for you. So that's what we are asking here for. So let's say for an example, I give a name as database, just for an example. And now the next option is about the username and password. So it's a common Scrum Shard 256 based authentication mechanism, which we create initially. So if you want to provide some sort of a name, let's say for an example, admin and some password, I can just go ahead and I can supply that, and this user and this database will get created. So now the next part, which is very complex thing, which NDB simplifies it very well for everyone. So which is like shards. So now we ask from the user how many shards you want. Do you want to increase the number of shard count? You can go ahead and you can simply select the number of shards count, and you will have them. So let's say for an example, I select 2 here for an example. So it has automatically created a shard name for me, which looks very friendly and which can actually help me to recognize that which shard it is. And by default, we create a 3-node replica set. So that's the standard what MongoDB also suggests and recommend. So we have a 3-node replica set within a shard. So which is each shard has 3 nodes. So similarly for shard 2 also, we have 3 nodes. The next important stuff, which is config server, which stores the metadata of the sharded cluster. So that also has to be a replica set. So that is also a replica set. You see the 3 nodes, right? So the VM names and all those things we auto populate. And if you really want to change it to something which you would like to do, you are free to do that. You can modify them as per your choice. So the next tab is your Nutanix cluster. Like if you have multiple nodes, you can select that which node where your primary should sit, or if you want to change the priority by ensuring that that node should be always primary, you can do that. And let's say if you have a 3-node, you will have all those options. You can distribute it as your company requires, right? So by default, if you want to really change the primary nodes, whomsoever it should be, it will go ahead and you can modify that too here. So now we have shard 1, shard 2, and config server, all those configurations available here. The last part, which is MongoOS, which is nothing but a router, right? So by default, we give it 1, but in case if you want to increase the number of MongoOS count also, you are free to do that. So I'll leave it as it is for now, and I'll just click on next. And once I click on next, this is I'll move to the additional configuration page, which will allow you, in case if you want encryption or native encryption of MongoDB, which is TDE, right? So transport data encryption, which is encryption at rest. If you want to do that, you will be able to enable that with some pre-configuration already done within NDB. And once you click here, it will allow me allow me to go ahead and enable native TD facilities for the MongoDB. So currently I don't have that configuration available here. So that's why it's throwing me an error. It clearly says that if you really want to do that, you just go to that settings page and you enable that KMS settings, and you should be able to do that. For now, I'll leave it as it is, and I'll just click on next. So now it will show me a clear information that what exactly I'm going to do now. So what would be my sharded cluster name, where exactly it's going to be deployed, what kind of a network profile I'm going to use, what kind of a software profile will be used here, and SSH keys, NDB user, the instance, how they are configured, and all those stuff will be there. And the only final thing what I need to do is just click on provision, and it will go ahead and it will start provisioning for us. So for now, because it may take a bit of time, keeping that in mind, that I have already done a provisioning, and once I click on provision, it should go ahead and it will create an operation for me. And under operation, I'll just go ahead and I'll just select 5 days status completed and shard provision. So I have specifically chosen the sharded cluster, which we are going to talk about. So if you see that, as soon as I click on that provision button, it will submit an operation for me, which will say that provision sharded database. So if you see that, it goes ahead, it does some sort of pre-processing, it retrieves a lot of profile information, your network software and all those stuff. Now the next critical part, which is creating the virtual machines, right? So it goes and it allows the creation of virtual machines in parallel. All the database. So let's say for an example, you have selected two shards where you have three nodes in each shard, which means that you have 6 nodes for it, and a config server replica set, which is another 3 nodes, and a Mongo S. So altogether, they are 10 nodes. So 10 virtual machines we are talking about. So NDB goes ahead and it will start creating those database VM all in parallel. So we can ensure that the creation time reduces. So all your VM provisioning and everything starts in parallel. And here are some processes which you see that 8 minutes it has taken, 9 minutes, 12 seconds for creating virtual machines. So once it is done with creating virtual machines, it will go ahead, it will check the network reachability, whether NDB is able to reach or not, or each nodes, they are able to talk to each other or not, and all those things. And it has to configure some network and restart the network services, all those things it will go ahead and do that. And this is very critical thing, which is attaching storages, right? So which is like for your data, right? Slash MongoDB data. So the actual path where exactly you are going to store your data. So those storage path, it is going to attach it to your VM. It will create that based on your choice. It will attach that and all those things it will do. Then it will configure MongoDB as a service for you so that in case of your VM reboot or any kind of management activity, if you need to do, and if you want to manage it with via service, it goes ahead, it configures that. Then the last part, I wouldn't say it's last part, but yes, we are ending in the provisioning phase. So where it has to create the config server and shard replica set configuration, which is like creating or converting each individual node into a sharded replica set and all those stuff, right? So it will perform those things and then start the Mongo S service and add the entire or probably club everything together to make it a MongoDB sharded cluster. So once it's done with all these things, right? So then we go back and we tell that we have done the job, we have completed the provisioning of a sharded cluster, and now we need to know and we want to manage it within NDB. So we register each of these entities in NDB. So it performs the registration, and eventually, if you see that within 28 minutes, right, you were able to do all these things. So in the backend, there are a lot of work has been done, but probably looking very simple. But yes, there are a lot of things which happens in the background, and we were able to finally provision sharded cluster. So once we are done with that, there's another set of operation which you would need to do, right? Because we have, which is associating the sharded cluster to Ops Manager. So when I say associating that database with Ops Manager, this actually means that now whatever we have provisioned now, the sharded cluster, what we provision now, we need to bring it or deliver it or give it to Ops Manager, right? So once I have the sharded cluster available with me, what I would need to do is I'll just click here and I will see under action, I will see an option which is called Associate Ops Manager. So which says that here it says that Ops Manager is already associated with this database. And if you wish to deassociate or restructure, reach out to support. So here what we are actually suggesting is that in case your sharded cluster is provisioned and now actually you need to associate it to Ops Manager. So you would just click on this Associate Ops Manager button and immediately it will go ahead and it will submit an operation for me. So I'll just go back, status completed and shard provision. So you see that here is an option which says associate database with Ops Manager. So now an association operation comes in. So here what we do is we have whatever we have created, we need to push it to Ops Manager. So we do some sort of pre-processing and we see what inputs is all the things because eventually we have to create a payload and we have to push it to Ops Manager. So we validate those inputs, everything. We validate if the MongoDB version what is being used to provision the sharded cluster, does Ops Manager also satisfy that? If it does not, we throw that error that you have to enable that version in Ops Manager. So we do that validation of MongoDB version. We configure storage for Ops Manager agent. So Ops Manager agent is nothing but, probably you're familiar of automation agent, right? So automation agent also generates its own logs. It generates backup related, monitoring related, automation related logs. So we wanted to ensure that we have a dedicated storage for these logs too. So we create that, and we go ahead and attach those disks too. And a very critical thing, right, which is like Ops Manager agent installation. If you're familiar with Ops Manager, right, so you know that once, if you want to deploy an Ops Manager via only Ops Manager, you need to have a MongoDB agent, or probably an automation agent, we can call it out, that has to be available and running on each database VM. So we do that for you too. So we go ahead and we install the automation agent on each database VM, and we perform the registration of that database to Ops Manager. So eventually, once you are done registering, right? So once everything is done, your metadata update and this operation gets completed, right? So it takes just around 15 minutes. And once it is completed, you will be able to see that entire project, or probably the database cluster, in Ops Manager. So for that, if I want, I can just go to settings, MongoDB Ops Manager. And if you see that in this Ops Manager, I have one associated or one database which is being onboarded here. So I can just copy the project name and just go to, this is the Ops Manager, which we were talking about. And I just paste this Ops Manager, I mean the project's name here. So if you see that, if I go to this project, I will be able to see that I have configured each and everything. So which starts from configuring the agents, enabling the monitoring, backup, and automation service on each database VM. Probably this view would be better, where you have the monitoring, backup, and all those things, right? Whatever we need, right? To make sure that the database gets onboarded to Ops Manager, as well as the agents can talk to each other, and the database can be managed via Ops Manager. All those things gets available here, and you have the database available here too. So that's what Associate Ops Manager does. And once the association works completes, right? So the next part, which is very critical thing, which we always talk about, and which is a must thing, which is the capability to backup and restore the database. So for that purpose, I'm just going to Time Machine, which is NDB's solution for backup recovery, point in time recovery, and all those stuff, right? So I just click on Time Machine, and I have this shard provision TM, which is the associated time machine for my sharded cluster. If I click on this, and I believe Anand was showing that in one of his slides, that these are the points, right? This is a continuous oplogs, which database is, the time machine is, I mean, talking to Ops Manager, the database gets involved, and all these folks gets involved, and they pull out the Oplog slices, snapshot, and all those stuff. So we have so the configuration right now is something like a snapshot every day, and a continuous tailing of Oplog happens here. So in case if a situation comes in, and Anand was talking about, like, you can go back and to any point of time when you want to perform a restore, I can just click on actions, I can click on restore database, I can select any point. In case if I want to perform a restore on a snapshot base, I can just click on this blue line, right? So once I click on this blue line, it will automatically select the snapshot which NDB has taken by its own. And in case if you want to do some sort of a point in time recovery, so I can just manually probably select it here, and or probably just type it in here, and I can just click on restore. So this will initiate a restore operation for me, and I have already done that operation. And let me just go back to that. Here we go. So I'm sorry, one more thing we need to do is, which is very important, which is enabling a time machine for us. So since now you have already associated the database, right, to Ops Manager, you need to ensure that there is another operation which is called enable the time machine for MongoDB Sharded cluster. So in this operation, we go ahead and we ensure that our time machine goes to Ops Manager, it talks to it. There are some backend third-party APIs which actually talks to Ops Manager and ensures that the backup and all those things can be taken properly. So for that, we enable this operation. This takes just around a minute of time, where it validates if the prerequisites for managing the backup and all those things is all sorted or not. It creates some entities for NDB. It tells or it enables backup in Ops Manager. It creates all the staging drives on all node, which is like a like for your log backups and all. We create a staging drive so that we can push the Oplog data as fast as we can, right? And we create those log storage, and at the end, it enables the NDB backup. So once this is in place, your automatic snapshot will trigger, and all those stuff will happen, and now you can perform the restore or snapshot. So as soon as your backup and your time machine is ready, this operation gets completed. NDB will go ahead and immediately it will perform the oplog backup for that particular sharded cluster, as well as it will go ahead and it will perform a sharded cluster snapshot too. So if I talk about the log backup and all those stuff, right? So if you see that it has just taken 32 seconds in this case, where it has done some pre-processing, right? Discovering database and populate EA nodes. EA node is like from which node actually it has to take the backup, whether it's primary, secondary, based on the configuration, it identifies that, and then it performs the oplog snapshot, copies the log, right, from whatever the snapshot it has taken, and pushes it to object store. So that is what it does. It does all those things. In this case, it has done it in 32 seconds. And the next part, what it has to do is it has to perform a snapshot operation. So the snapshot operation also, like if you see that it has taken 5 minutes, 32 seconds to perform the snapshot. And here, again, it has done some sort of pre-processing, discovering, identifying EO node, refreshing the application metadata of each VM and all those stuff it has to do. It performs a pre-snapshotting. So very important thing I just would like to call out here, right? So which is like when we are talking about snapshots, right? So our snapshots are completely irrelevant of size. So we don't care about like if you have just 100 GBs of data on each node, or if you have some sort of like terabytes of data on each node. So we don't care about that. We just go to that particular disk, we take the snapshot of it, and we store it in object store. So we are capable of that, and we can do that. So it like the traditional way, right? So the traditional way, if I talk about taking a backup of a sharded cluster, I mean, it's definitely very difficult because you have cross-sharded transactions happening across the shard. You don't have an exact point in time when when your entire cluster is ready for snapshot. That coordination is done by Ops Manager for us, and you go ahead and once Ops Manager tells us that I'm ready for that snapshot, we go ahead and we take the snapshot on the disk level. So our disk level snapshots are pretty fast. So so once it does that, it performs the snapshot for us, and we are good to perform a restore if you really want, right? So you can just perform a restore operation here. So this is one of the operations. So just to so again, the same thing, right? Like we have to do a lot of pre-validation to ensure that whatever the point you're trying to restore or the snapshot, it's all good, right? So we do in the back end a lot of validation, and we perform the restore there. So for restore, we validate and initiate Ops Managers the restore operation, where we ask or we tell Ops Manager that, hey, I'm going to perform a restore. So can you make sure that whatever has to be done, you take care of that? So it goes ahead and it does that, and and a very important thing, right? So which is like replicating a snapshot. So before we perform any kind of a destructive operations like restore, right? So we ensure that we also create a backup of whatever you have, right? So we ensure that we replicate some existing snapshot or whatever you wanted to use. You have already ready that snapshot, and we replicate it to other PEs, and we ensure that that is already available, so that in case if something goes wrong, you still have the capability to go back. So after we have those things, we refresh the metadata from each node, and we advise ops manager that, hey, please go ahead and help us with the ops manager restore. So ops manager performs the prerequisite thing like stopping the database instance during that time and making the cluster being ready. And then we go ahead and we perform the restore using that snapshot, using our native technology of time machine. And finally,
And
your
Ishwar, just a really quick time check. We probably will be wrapping the demo, this part of the demo up in like 1 or 2 moments. Are you still on track?
I think we are good because we have already completed the sharded database. So I just would like to give a quick a UI view of how exactly snapshot, and if somebody needs to perform a snapshot on an urgent basis or a manual snapshot, how they can probably do that. So thanks for that, Mohammed, by the way. So here in actions, you can go ahead and you can perform whenever spontaneous log catch up or snapshot and all those stuff. So I think that's it from my side. If you have anything, happy to answer that.
Perfect, perfect. Thank you so much for Ishwar. That was very informative and thorough. We're getting a slew of questions here, and we have one more quick demo, so we're a little bit um, crunched on time. But let me see if I can at least squeeze one question in. Again, so MongoDB folks, Anand and Ishwar. One question we have received is that from somebody in the audience is saying that the DBA team, where they're running MongoDB sharded clusters in production, the DBA team is telling them that backups and recovery are taking longer and longer, and it's becoming a timeline risk. How and what is it that NDB does differently that, could help resolve some of these issues? Anand, you
Sure.
wanna? Sure, go ahead.
Yeah, sure. Absolutely, Mohammed. Let me take that. And thanks a lot, Mohammed. So this is a great question, right? So if you look at a multi-terabyte scale, right? So backup for a sharded cluster is essentially a coordination problem, right? So like Ishwar was demonstrating, when you have to take backup for multiple shards, it's not just shards, it's config server. And the important thing is getting a consistent recovery point across all of them in a carefully orchestrated fashion. So what NDB does is it kind of uses MongoDB's official third-party backup API to quiesce the cluster. Now, this includes pausing the balancer to stop the chunk migration during the snapshot window. So you have a stable, consistent state across all shards, right? So all of this is done automatically. Then NDB takes a volume level snapshot of the underlying storage simultaneously. Now, this combination gives you both consistency guarantees at the MongoDB layer and the speed at the storage layer. So you're not streaming the data out, you're just snapping the volume. And restore is also one click. And you automatically validate shard consistency before completing it. Right? So basically, to summarize on speed, because this is a volume-based snapshot, backup and recovery scales sublinearly with the data size. And in our internal some of the validations, we have been able to restore like 8 TB in under 16 minutes on the Nutanix infrastructure. Right? And the most important point, even as a cluster grows, the time does not grow proportionately the way it would do in a, let's say, like a traditional streaming based approach. Right? So I hope that answers the question.
Excellent. Thank you. Much appreciated, Anand. All right. So we have very little time left. Let me see if I can quickly breeze through a demo of the functionality that we spoke about earlier for MySQL HA. Let me quickly share my screen. All right. So let's start with the familiar dashboard screen. And again, this is very similar to the experience that many folks would have with NDB if you're already a user. But if not, then you basically get into the database view. You could either select your sources or start from the overview section if you wanted to, and then select provision. We're going to provision a MySQL database, but instead of making it a single instance, we're going to go for the new HA functionality. I am going to make a database for my enterprise data, and I am going to, since this is an HA cluster, an HA database, let me select a couple of clusters at least. You can actually do more. And let us select the network profile associated with the HA cluster. We're going to go with the default IPs from a DHCP perspective for this demo, but you can also select manual IPs. And then follow that up with the database server VM properties, where you define your profiles for compute, for software, and you also need to select which of your databases will act as primary. I will select this one. For today's purposes, we're not actually going to provide the secure shell public keys. We're going to progress with the database as is. Let's provide an enterprise InnoDB cluster and provide the credentials here. For our purposes, and by the way, we received another question about the stack that this HA of MySQL implementation is leveraging. As MySQL practitioners know, there's several different variants and options when it comes to MySQL configurations. With this specific stack, once again, we're using MySQL DB as a storage engine. We're using group replication, and we're using MySQL router and MySQL shell from a tooling stack. So you can configure. I prefer to have the router, though it's possible also to not provision router and use alternative load balancing or proxy mechanisms. In this case, I'm going to go with the defaults, and let's add a MySQL instance and add an initial transaction database name, followed by, let me provide my credentials, and I will also select the HA database parameters, beyond which I'm going to, let's say, associate this with a specific department. And that's it. It literally, that's all it takes. You're done. It is now being provisioned, and you can check its status in the operations view that we've already spent a few moments looking at in earlier demos today. As they say, here's one I made earlier that was provisioned earlier today, and it takes a few minutes, obviously, but this is kind of like an offline operation, and you can then monitor the operation as it's happening today for status. And when it's done, you can then go ahead and browse your database as you can with any other NDB provision database, and manage it from here and add additional databases and monitor your individual nodes. And that's it. It's literally that simple. This follows the same mechanism that people are familiar with NDB, including for example, some of the one piece of functionality that many users are very much fond of and are always sort of making use of is the show IP equivalent. So what I just did there, you can use that to just guide your process from an initial perspective, and then use that to get an get an API equivalent, which you can then use in your own internal automations. And then that's it. You would be done. So that's it for the MySQL HA demo as well. Let me check quickly if there's any other questions. That's all I'm seeing so far. Thank you so much for everybody's attendance today and for the engagement. Before I sign off, Anand, Ishwar, first of all, thank you for your participations. Parting comments, or should we let everybody go?
No, thanks a lot, Mohammed. I just have one final comment to make, right? So for the folks on the audience, if you are already using MongoDB or evaluating, or if you have a use case where you need the backup capability or a more deep dive, feel free to drop us a note, or you can drop us like a small note on the message, or can reach out to us, yeah, right. So we'd love to engage with you. We'd love to know your requirement and how best we can help you.
Excellent,
Thank you.
excellent. Yeah, I'm seeing some very positive comments there. Thank you, everybody, for joining. And yeah, please do reach out. We look forward to hearing more from you about this in the future. And we'll see you in a future Tech Talk. Looking forward to it. Have a good one, everybody. Bye.
Thank you.